Andrew here with another episode of Circuits Anonymous. And on today's episode, we'll go over what positive and negative air pressure is and find out which one's the best at keeping your PC cool under extreme conditions. I would like to start with a little theory on air pressure in relation to how PC cases are cooled. Typical computer cases have fans at the front, at the rear, and at the top. And while they do exist, PC cases with fans at the bottom are few and far between, so we can ignore them for the sake of our lesson. Every fan is capable of moving up to a certain amount of air per minute, measured in CFM or cubic feet per minute. When the amount of air going into a system in CFM exceeds the amount leaving, that system is considered to have positive air pressure. And on the contrary, if the amount of air going into a system is less than what is leaving, then that system has negative air pressure. So, which one is better for computers? It may seem at first glance that the positive pressure may have the upper hand, since from a normal perspective, blowing air on something typically cools it down. And that's even how CPU coolers and radiators work. Benefits of a system with positive air pressure include having more fresh air entering a case, which can bring the overall internal temperature down. Another benefit is the possibility of less dust inside the case. Since you can filter your intakes, most of the dust will get caught in the filters and not actually get inside of your case. When dealing with negative air pressure, you can actually technically get more cooling performance, since more air leaving the case requires air to be pulled from every available nook and cranny. This includes any present intake fans, ventilation holes, and usually you get a little more dust inside your case this way. The differences in performance between the two can be explained through thermodynamics. Heat likes to move from where it's hot to where it's cold. Inside your case is most likely warmer than, let's say, your room. Therefore, heat is probably already escaping, albeit slowly. That's where your fans come in. Fan intakes do help get that cold air inside, but it's sort of fighting against the natural order of things, since hot air wants to escape and cold air doesn't really want to go inside of it. Obviously, intake fans force this to happen, but this does end up being the fundamental reason why you will typically see worse performance from a positive air pressure system. Now, on the opposite end, hot air wants to go someplace cooler, so it benefits more from fans that allow that transition. In this case, our exhausts. But not everything is so cut and dry. If there's not enough air entering a system to drive the exhaust in a meaningful way, or if your fan intakes get clogged with dust, then you might end up at square one anyways. If only there was a meet-in-the-middle kind of compromise. Well, duh, there is. Neutral, or more like near-neutral air pressure. In this scenario, the amount of air entering and leaving the case is about the same. This configuration balances the performance aspects of negative pressure systems with the dust preventative qualities of positive ones. Let's take my system as an example. I have two 140mm intake fans at the front with one 140mm exhaust at the rear and a 240mm radiator fan setup at the top. This setup would be considered slightly negative since I have more fans blowing air out than in. We'll take a moment to see the temperature of the system at idle. A good temperature to take note of here is actually on the graphics card, at least in my case, since it's the only significant heat-producing object in my case that's actively cooled by air. I should also note here that the fans on the graphics card do contribute to the nature of the air pressure in your system. At idle, we're experiencing a temperature of 40 degrees Celsius. Note here that the ambient room temperature is about 17 degrees C. Also note here that the fans aren't actually spinning yet, either. That's a feature on the Strix line of graphics cards from Asus, which don't actually engage the fans until the card hits a certain temp. But moving on. After 10 minutes of stress testing my graphics card, thank you for Mark, the graphics card temperature topped out at about 65 degrees Celsius. Now I'll switch the fan orientation on every fan in my case and test again. This will cause the system to have a slightly more positive air pressure. After the switch, I saw an improvement of about 3 degrees, with the graphics card topping out at about 62. Honestly, this falls within a fair margin of error, and if I had more sensitive equipment to measure I would definitely do that. And maybe we would even see some more drastic results. But probably not. It's pretty easy to tell just by looking at a case whether or not there's going to be an issue with airflow. My case, for example, the Enthoo Pro M from Fantex, has great airflow denoted by the large ventilation holes present on the rear and the top of the chassis, as well as the large filtered mesh portion in front of the two 140mm intake fans. This allows for either positive, negative, or neutral air systems to flourish just fine. Such is not always the case with other PC cases. Ironically, Fantex also has a case which falls into the category of fail when it comes to airflow, the Enthoo Evolve. It's a pretty case and even shares the same internal layout as the Pro M, but with one fatal flaw: a completely blocked off front panel. The design is sexy as hell, but it has absolutely no functionality, as it pretty much starves the intake fans behind. This causes problems mostly with radiators, but that's probably a topic for another video. Overall, as I suspected, having neutral airflow in your system is the best of both worlds, providing both excellent performance while mitigating dust. I should note here that if you do live in a particularly dry and dusty environment, this may not apply, but for the majority of people, it should do just fine. But please let me know what you prefer in the comments section below. It occurred to me recently that I don't engage my audience enough as I should. Either way, please toss this video a like and get subscribed if you aren't already. This was Andrew with Circuits Anonymous, and I'm signing off.